give you one more question to work on, and then we'll start to do some integrals. What I want to do. Okay, so work on this problem for another 5 minutes. As usual, you can ask questions during the time. All right, think about using the previous example. What should be your u? And then make the translation table, and then actually do the translation. Okay, so what did we get for this? What did you choose to be your u? The denominator. Okay, so let u equal x cubed minus 2x plus 5. Now, what is my rule of thumb? My rule of thumb is this a good u? Okay, so you should ask yourself, is the derivative of x cubed minus 2x plus 5, is its derivative or some constant multiple of that derivative sitting outside multiplying the whole thing? Okay, well, the derivative is 3x squared minus 2. And yes, it is. The derivative is sitting outside multiplying the whole thing. In this case, there's a constant multiple attached to it, right? So this is generally good. Okay, so let's use this as our translation table. So in my translation table, I take the derivative of my u, and then I algebraically solve for dx. All right, now we actually do the translation. Okay, so for now, the numerator, I'm not really sure what to do with yet, right? Because 9x squared minus 6 does not really appear in my translation table. Remember that we only look at the first and last parts of the translation table. The denominator is very easy, right? That's just what u is. X cubed minus 2x plus 5, that's a u. And then my dx, I get from the last line of my translation table, I get du over 3x squared minus 2. All right. Now, again, like I said, it's okay if you have both variables in the same integral as an intermediate step, but eventually it has to get boiled down to one variable, right? So if I hopefully the x's should cancel out. So if I factor out a 3 here, I get 3 times 3x squared minus 2. And in fact, now I can see that the x's actually do cancel out, right? 3x squared minus 2 actually does cancel out. And I'm left with, let's see, I'm left with 3 over u times du. Now, once all the x's have canceled out, once you're down to an antiderivative that has only the variable u in it, that means you actually can find the antiderivative, right? You cannot find the antiderivative until you only have one variable. Okay? That's very important to remember. You cannot proceed with fundamental theorem of calculus or finding an antiderivative or anything like that until you only have one variable. Okay, so can someone actually then say, what is the next step here? And I see there's only one variable, so I should be in a position to take the antiderivative. And it should also be a lot easier than the original, right? You should be able to look at this and say, aha, I know the antiderivative of that, right? That's just a formula I know. I think I saw Priscilla typing something. Could we write this as 3u to the negative 1? Okay, good. Actually, let's write it like that. That might actually, in case someone's unsure what the answer is, that might remind them of kind of what it is. So this is the same thing as 3 times u to the negative 1. So how do I find the antiderivative of that? Keep in mind, is this like a normal power rule? Do I add 1 to the exponent and then divide by the new exponent? No, that wouldn't make sense, right? I can't do that. I can't divide by 0. So that the usual power rule doesn't work for this. Someone know how to deal with this? ln, so something like ln. So can you actually tell me the answer? So yes, it's something with ln. So what is the actual answer? 3 ln absolute value u. Good. And then I go back to x, right? Because the original problem was asking me for a function in terms of x. So my final answer should be a function in terms of x. So I get 3 ln absolute value of x cubed minus 2x plus 5. So that is my final answer. All right.